We introduce reduction of energy consumption using machine tool digital twin. There are interests emerging in production with less environmental and social impact. The main idea of sustainable manufacturing is using resources more efficiently. Especially in the manufacturing industry, one of the challenges was reducing the energy consumption per part. However, the process of designing the energy efficient process was inefficient, which means it often relied on trial and error, and previous research depended on experimentally measured data. Therefore, we suggest the use of a digital twin, which is a digital replica of an actual machine described with physical and mathematical models. The digital twin is able to estimate the result of manufacturing process without actual operation of the machine tool. First, we introduce the process of building the digital twin for estimating energy consumption. One of the main energy laws occurs in its motion system. We introduce a real-time identification of model parameters in feed drive system using recursive least squares. This is the feed drive, which generates relative motion between workpiece and tool. To identify its model parameter, we built a dynamic model which includes equivalent mass and friction. From actual velocity measured from the system, the dynamic model estimates its driving force. Next, the estimated value is compared with the measured driving force. Then the recursive least squares method updates model parameters for every loop using the error between estimated and measured force. This is the demo video of the feed drive model identification process. Using a simple reciprocating motion in each axis, the mass, viscous friction coefficient, and Coulomb friction are successfully identified. Next, the other energy loss occurs in material removal process. We utilize the integrated form of the cutting force model. Without using additional force sensors, we only used torque signals measured in the servo motor. We regarded the force difference between non-cutting and the cutting region as force required for a material removal process. With a few trial cut, the cutting force coefficients were identified and the force was estimated with accuracy of 80 to 90%. Now, using the digital twin, we searched for optimal machining condition for each block or a line in the part program. By integrating the numerical control kernel model with dynamic model and the cutting process model, we estimated the energy consumption in each block. Using the genetic algorithm, feed rate and spindle speed for each block was optimized. This is the demo video comparing the original process and the optimized process. Even though the total time increased about 11%, the energy consumption was reduced by 7.5%. We successfully demonstrated the simulation-based energy optimization. To summarize, the digital twin can contribute to realizing the paradigm of sustainable manufacturing. The digital twin can estimate energy consumption without operating actual machine. Therefore, design of energy optimized process using simulation models is possible. We can produce same parts with less energy. For more information, please contact our advisor or visit our website.